Hi students, in this video we'll discuss finite state transducer. Finite state transducer is nothing but finite state machine with output. Right, finite state machine with output. So if I take my finite state machine or finite automata, it is just a language recognizer. Right, so the output will be either accept or reject, right, true or false, valid or invalid. I'll get output like this. It is just a recognizer, right? So if I need some output in my finite state machine, I should go for this transducers, right? So we have discussed a few DFA sums, right? So what I'll do, I'll design a DFA machine based upon the condition given, right? So if I have the question like design a DFA to accept the strings starting with AB, right? So after designing that DFA, if I give any input to my DFA machine, if that input begins with AB, my machine says it is a valid string. It will accept that string. If not, my machine says it is an invalid string and it will just reject it. So my finite automata, it's just a language recognizer, right? So other than this accept or reject, it won't give you any output. But if I need a specific output, I should go for transducers. So transducer, I have two transducers, Moray machine and Mealy machine. Moray machine is a 7 tuple machine, right? I'll have a 7 tuples. Set of finite states, alphabets, output alphabet. This is input alphabet, output alphabet, start state, final state, and transition, and my display function. Right. Next is Mealy machine. Mealy machine is a 6 tuple machine. Set of finite states, input alphabet, output alphabet, start state, final state, and my transition function. Just the display function is missing here, right? So finite state transducers, I have two types, Mealy machine and Moray machine. Now we'll discuss the sum in both the types. So first I'll consider my Moray machine or Moray machine, right? Suppose if I want to design a traffic light, right? Traffic light, I want to simulate a traffic light. So what I can do, so as you all know, traffic light means I'll have a green light for some interval of time, some period of time. Then I'll have this yellow light for some period of time. And at last I'll have this red signal for some period of time. Right? So I want to simulate this traffic signal using my Moray machine. So in this finite state transducer, every state will be associated with an output. As I said, finite state transducer is nothing but finite automata with output. So every state will be associated with an output. So I'll draw my traffic light, my green signal, my yellow signal, and my red signal. Right, you all know this green signal, right? It will be this green signal, it will be there for some period of time. Assume, right? If I design a traffic light, traffic signal, so that my green signal, it is for 70 seconds. So this green signal will glow for 70 seconds. Once this 70 seconds is over, automatically, right? I'll be moving to this yellow light. This yellow light, this state, it's associated with some output. That is, this yellow light, it should glow for some period of time. That is, I'll make us 10 seconds. Right? Then once this 10 seconds is over, automatically, right, there is a shift to red light. Red light, it will be there for some, I'll write as 80 seconds. This is how I am designing my traffic. I'm simulating my traffic signal using a Moray machine, right? So how many states I have? I have 3 states, and each state is associated with an output. Right, I have a display function in more machine. Each state it's associated with an output. Green light for some period of time. Once that period is over, right, it will move to yellow light for some period of time, then red light some period of time. Again this continuous, right. So this is my traffic simulator using my more machine, right. Next is I can see an example for melee machine, right. So my question is like I have to design a melee machine which reads an odd parity bit after every 4 binary digit that it reads, right. Design a melee machine that adds an odd parity bit after every 4 binary digits that it reads, right. So I have to design a melee machine, right, so that it reads a binary 4-bit binary number, right. It will read a 4-bit binary number. Once this 4 bits is read, it should generate a odd parity bit. So input will be a 4-bit binary number, but output will be 5 bits. How come I got this 5th bit? It is a odd parity generator bit, right. Odd parity generator bit. So I'll tell the question once again. I have to design a melee machine such that the melee machine adds an odd parity bit after every 4 binary digits that it reads. It will read a 4-bit number, then it will give you a odd, it adds to this 4 binary digits, it will add an odd parity bit. That is, suppose if it reads 000, right, this is my input. So what output I should get? I should get an output like this. So this first 4 bit is same as that of input, right, same as that of input, but along with the parity bit. Suppose if it reads a bit like this, right, what will, if this is my input bit, what will be my output bit, right, same 4 digits plus a parity bit. This will be my output. First 4 bits are same as that of my input plus a parity bit, right. So we can discuss this sum. Right. So I'll write all the possible combinations of a 4-digit, right. So I'll write all the possible combinations. So 0 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So these are my possible 4-bit numbers, right. So my machine should be able to read all the possible 4-bit numbers and it should generate an output, right. Output will be a 5-bit number along with its parity bit, that is odd parity bit. So odd parity bit, if I add it, parity bit, if I add my parity bit here, it will be 1, right? Since it is odd parity, it will be 1. Here it will be 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1. Okay. Now I have to design a Mealy machine. You know, both Mealy machine and Moray machine belongs to finite state transducers. That is, each state is associated with an output. Each state is associated with an output. Here also you can see each state is associated with an output. Right? Likewise, in my Mealy machine also, each state will be associated with an output. Now I have to design my Mealy machine. So if you carefully go through these possibilities, right, you can check first 8 combinations is one part, right? You can check like here this 3 0 0 is same. Here again 0 0 0 0 0 1 0 0 1 0 1 0 0 1 0, right? Only the first bit changes. Remaining 3 bits are same for this first 8 combination and for this next 8 combination, right? So what I'll do is like while designing a Mealy machine, I'll make a branch. First one branch for this first 8 and another branch for this second 8. So how will I start? Right, so here I'll take this combination, right? 0 0 0 0 0, first 0, second 0, third, okay. And coming to this fourth, you take these two, right? If you take this two, first 3 bits is same, and fourth bit either it can be 0 or it can be 1. Take the next 2 combinations, first 3 bits it will be same, 0 0 1 0 0 1. Fourth bit it will be either 0 or 1. Similarly, check these 2 combinations, first 3 bits it is same. Fourth bit it can be either 0 or 1. So what I will do is like fourth bit it can be either 0 or 1, right? So yeah, what is your question? Adds an odd parity bit after every 4 binary digit that it reads. It will read a 4-bit number, gives you the output, and again it should be able to read the next 4-bit number and it should be able to give you the output, right? This is what it is expected in the question. So what I will do, I am reading first 4 bits 0 0 0 0, right? Again I'll be coming to my initial state to read the next set of 4-bit numbers. So I'll make a loop here, right? So taking this 2 combination, I have just made this. First 3 bits is same, fourth bit it can be either 0 or 1. Now I am learning my Mealy machine. As I said before, every state it is associated with an output. So, and here also I told input it will be a 4-bit number, output it will be a 5-bit number. How do I get this 5-bit output? First 4-bit is same as that of my input and the 5th bit is my parity generator bit. And so whatever input I am having, whatever bits I am having in my input, same bits I need in my output also. So what I will do here is like if 0 is my input, output also it should be 0. If 0 is my input, output should be 0. If 0 is my input, output should be 0. 0 input, output is 0. 1 input, output is 1. Right? And now see, I have just this is only for my input. Now how can I add this parity bit? You check here, for the first combination 0 0 0 0, parity bit is 1. Right, that's how I got my 5 bits as output. That's how 0 0 0 0 parity bit is 1. Right, so now you count, including this parity bit, I'll get my output as 5 bits. Right, so here 0 0 0 0 is my input. Now for this combination, what is your parity bit? 1. Right, this is Mealy machine. Mealy machine representation is different from Moray machine. In Mealy machine representation, for every state, how should I represent input and output? With a slash. Input slash, after the slash you will be having your output. Right. So Mealy machine representation is little different from Moray machine. So in Moray machine, I have this display function, but here in Mealy machine I am not having the display function. Right. So how will I be representing the input and output? Separated by a slash. Input and output, it will be separated by a slash. This is the representation of my Mealy machine. Right. So coming to this, and take the next combination. Right. 0 0 0 1 2 3. Fourth bit is 1. Right. So input 1, output 1 I have written. Then what about the parity bit? It is 0. Correct. Next, this is one set I said. Right. For the next branch, I should take this set. Right. In this set also, you take the first two combination. First 3 bits is same. Fourth bit, it will be either 0 or 1. So what I can do here, first bit is 1. So I'll write 1 here. Next, I'll write 0. Next, I should write third bit as 0. Fourth bit, it will be either 0 or 1. First 3 bits it is same. Fourth bit, it will be either 0 or 1. Right. Whatever it be, it should be able to read the next set of inputs. So I'm moving to my start state. So fourth bit, it will be either 0 or 1.